Hi, I'm Jocelyn Baduria, and I'm going to talk about the emotion recognition for healthcare surveillance systems using a neural network survey. Are you sad or happy? Emotion recognition is one of the latest topics of research in AI fields. This study focuses on identifying patients' emotion in healthcare industry with the use of deep learning technique neural network. Emotion recognition has been applied to three modalities, and the multimodal approach are the following: the speech expressions, facial expressions, and audiovisual or facial expressions help to identify the patient's emotion. There are three important tasks to perform the emotion recognition, and these are the essential CNN stages, known as the preprocessing, feature selection and extraction, and classification. This study focuses mostly on the patients and help the doctors in identifying the patient's early diagnosis of depression. The first application of emotion recognition study is on speech, or known as SER. SER is based on input communication audio signal. Understanding the meaning of information is not enough without the context of its emotion. The emotion preprocessing happens after the data collection. So the audio data is corrupted by noise, and feature normalization is applied to do the feature extraction. There are also other techniques for preprocessing input voice data, such as vocal cords, quasi-periodic vibration, MMSE, or minimum mean square error, or lag MMSE, or lag spectral amplitude MMSE. There are two types of feature selection and extraction used in this study: the global and the local features. The global features can be extracted by means of statistical mean, minimum and maximum value, and variance or standard deviation. The local features can be extracted through time and space to get the non-moving continuous speech signal states. In this study, there are two types of classification used: the HMM, or Hidden Markov Model, and ANN, Artificial Neural Network, and the Deep Neural Network. The Deep Neural Network is the most used because of its feature selection and extraction characteristic. The second application of emotion recognition study is on facial, or known as FAR. Images captured from camera is the vital source of input for facial emotion recognition. The preprocessing used in this study is a DNN with, or deep neural network with, batch normalization, wherein the translated input images signal are converted into pixel values, and the center of the focal of study is on the eyes and mouth before sending the data to feature extraction process. And the feature selection and extraction, they use DNN with different CNN or convolutional neural network using the C3D method. This is based on time and space three-dimension feature extraction. The FER classification method mostly used for for FER are SBM or support vector machine, NN or nearest neighbor, softmax, NFS or deep neural forest. In this study, they use softmax classifier by using a single DNN deep neural network with convolutional layers and ResNet or residual blocks. The third application of emotion recognition is on audiovisual or ABR. In here, they use a mixed input signal for emotion recognition. Three studies are used in ABR. These are the DNN, Deep Transfer Learning, and DCNN with multiple time models. For the preprocessing, most of the data used in preprocessing are taken from the video and audio signal with batch normalization technique. The video has advantages over the audio signals because it focuses on the face expression with specific emotion, while the audio signal is extracted and converted to 16 kilohertz using quantized mono signals. There are other techniques used also here in AVR, and these are multitask cascaded convolutional network, which extracts the face expression and video frames alignment. And the other is frame extraction from the beginning and end of each video. The feature selection and extractions used are mostly extracted from the video signals. The most used is deep convolutional neural network. For the classification, they use AlexNet to classify the emotion from the multimodal inputs and compared it with human identification of emotion. And here they also applied the brute force algorithm to find the maximum weight of the input prior to the fusion of input of multimodal signal, the speech and visual expression, to provide the final emotion prediction of patients. The challenges that they encounter during the study are mostly focused on the use of dataset and implementation in training. So mostly the focus of future work will address the issue of this degradation of training because of different dataset and the fusion method of speech and facial expression, and also the use of large dataset, and the data will be should be based on the real base dataset, not on simulated dataset from the same person recording. And this study is a main breakthrough for the healthcare industry. And if this will materialize, it will help a lot of patients and also the doctor in providing proper medication or guidance to the family of the patients and also to the patient itself himself. And acknowledgement to the authors of the research paper or survey paper and to their sponsor, Qatar National Research Fund. Because of them, this research would not be materialized. And thank you for watching.